So what we saw was on. So now let's see another function, right? Where now in this function what we are doing is this function, let's say again the function, it takes int n, right? And then the function what it does is for, and now we will take float, I is equal to n, okay, I greater than equal to 1, and I
minus minus
no, not I minus 1, but I is equal to I said I is equal to so let's do minus minus, and then we'll see different functions. Let's do what you are saying, right? And here I'm doing say that print I, okay, that's all I'm doing, okay. So what is the complexity of this function?
OFN.
On, right?
Yeah.
Now let's say I change this function from this to basically this part for float I is equal to n, I greater than equal to 1, and then I is equal to I by 2, and then I say
Okay.
print I. So what is the time complexity?
Same OFN because it will be ON by 2. So OFN.
Okay, so
Right.
this is okay, so this is not really on by 2, and let's see how,
Okay.
right? So what we are saying is that your I is equal to n, I greater than 1, and every time you divide your I by half, right? So
Oh,
let's say to begin with, you have your n is 16, right?
yeah.
So then the first time basically you execute your n or your I is 16, right?
Okay.
Then after that what happens is your I becomes 8,
8,
right?
yeah.
Then what happens is your I becomes
4,
4. What happens is your I becomes
2, 1.
2,
Yeah.
1, right?
Yeah.
And
Yeah.
at that time it will stop.
Stop.
So now you just see how many times we basically executed this function.
5 times.
How many times did we execute?
5 times, right?
5 times, right? Okay, so your n was originally
16.
16,
5 by 16.
right? But it got executed 5 times, and to make it little bit simple, let's make it I greater than 1, right? So this time it
Okay.
won't be executed. When it is 1, it won't be executed, right? So how many
Okay.
times it got executed? 4 times.
4.
So now let's say instead of I n is equal to 16, n was 32, n is 32. How many times it
Okay.
will be executed?
5 times.
5 times, okay.
Yeah.
Let's say your n is, instead of 32, your n is let's say 50. How many times will it be executed? Let's count, right? If n is 50,
Yeah.
right? So first
Okay.
it is 50, right? One time it is
Yeah.
25,
12.5.
then 12.5,
12.5.
right? Because it is float. Then what?
6.25.
6.25, right? Then what?
Yeah.
3 point
3.125.
3.125, great. Then how much? 1 point
Point.
whatever, something,
5.
right?
Yeah.
Something
Something.
x, and it
Yeah.
will stop there, right? So how many times it got executed? 1, 2,
1,
3,
2,
4,
3.
5, and
Ah,
this point it
6
will
also.
stop, right? So 6, right? So
Yeah.
if you see what is happening is, and let's say now I is 64, n is 64, how many times will be executed? Let's see, right? So 64,
5. 6
32,
times.
6 times, right? So still 6 times.
Yeah.
So
Yeah.
if you really see, n 64 is equal to what? 2 raised to 6 is equal to 64. Yes?
Yes. Yeah.
2 raised to 5 is equal to 32, right?
Yeah.
So then you see that, and if you want, so we are executing is 6 times. So let's say that means, you know, 6 is equal to log of 64 base 2.
Okay. Yeah.
Okay, so that means your time complexity is really O log n
Mm-hmm.
base 2. Got it?
Okay. Okay.
Because every time you are breaking your input into the half.
Yeah.
Got it? So that's why it is
Mm-hmm.
O log n base 2. And this is the same principle that goes in the binary trees or heap, right? Where binary
Mm-hmm.
tree, if you see,
It splits
right?
into two.
Yeah, it splits into two, right? So
Yeah.
that's why it is O log n. Now let's say if this is instead of I divided by 2, I do I divided by 3. What is my time
It will
complexity?
log n3, right? N to
Yes,
the base 3.
yes. So basically it is going to be log n base 3,
Yeah.
right? So the same way, right? So that's how this thing, that's how it is derived, why it is log n base 2.
Okay.
Okay, got
Yeah.
it?
Yeah. I got it.
Okay, so whenever you break up your number of inputs in half, right, repeatedly half half half, every time you keep breaking it into half, your time complexity, it changes logarithmically. And if it is half, then it
Okay.
is log n base 2. If you divide it, if you break your input into 3 parts, then it is log n base 3. If it is 5 part, log n base 5. It is 10 part, log n base 10.
Okay. Okay.
Okay, so that's what
Yeah.
it is, right? So now let's look at, let's change our function a little bit, right?
Yeah.
So okay, so now let's say your original function basic, okay, and let me just remove this part as well. So let's say your function is now it has 2 loops. Okay, so the 2 loops are like this, right?
Yeah.
First loop is you are doing this, and another loop is you are doing this, right? So we saw that for this loop the time complexity is what? O
N.
n. And for this loop, what is the time complexity?
O log n
O of log
to
n,
base 2. Yeah.
right? Base 2. So what is the total time complexity of this function?
O of n.
O of n.
Because it is O of n plus O of log n. Yeah.
Okay, so it is O n plus O of log n. And when it is something like this, right, when it is addition, what you can do is you can discard
The smaller one.
the smaller one, right,
Yeah.
or the less complex one, which has
Yeah.
lower complexity, right? So that's how, that's what you can do. Now we saw, earlier we saw that time thingy, or I showed you the graph, right? So let's say if I have to show you the graph again, then let's see how does the ON and O log n will look like, right? So let's do some mapping here. Okay. So we'll do 1, 2, at least do till 8, 3, 4, 5, 6, 7, and 8, right? And again 1, 2, 3, 4, 5, 6, 7, and 8, right? So 8, 1, 2, 3, 4, 5, 6, 7, and 8. So when it is ON, it linearly increases, right? Something like this. So it is more of like this 45 degree at 45 degree angle, right? So this is like 45 degree. Now when it is, this is your N, and this is your execution, right?
Yeah.
Execution, how many times you are executing the set of instructions. So let's say when it is let me take a different color. Let me take this maroon. And so when it is O log n, so when it is 2, right?
Yeah.
So when the number of input is 2, then you are executing it just one time, right?
Yes.
Right.
Yeah.
When it is 4, you are executing it 2 times, right?
Okay. Yeah.
Yeah. When it is 6, sorry, when it is 8, you are executing it 3 times.
3
Yes.
times. Yeah. Yeah.
Okay, or something like that. So if I have a much better, I mean if I draw it much better, the graph would look something like this over a period of time. And when it is 16, it just reaches 4, so it becomes more like this. Okay, so if you see is, so when you see your execution or your time complexities for function, if it is like O n and O log n, you see as n increases, this component is much higher than this, right?
Yes.
This linear part is much higher than this, right? So that's why you can discard it.
Okay. Okay.
Okay,
Yeah. Yeah. Got it.
got it? Okay, so
Yeah.
now let me stop the recording.